As chair, good morning to and good afternoon to everyone. As chair of the high-level forum, it's my great pleasure to open this webinar and welcome all of you for joining today. First, I'd like to warmly thank Harry Kulmala, Julia and Clement, the organizer, and all the speakers for their dedication and the quality of their work in preparing these events. This discussion is fully aligned with the mission of the high-level forum. For those who do not know the high-level forum, it's an international network and innovation ecosystem which bring together executive and decision makers from the world of education, research, industry, business, economy, and public authorities. And all these ecosystems are deeply engaged in the management or promotion of innovation within the regional ecosystem and often worldwide. Next, Julian, please. We are actively preparing for our next three-day annual summit. It will be held in Grenoble next year in February 2026, and it will be a key opportunity to deepen our exchange and continue our collective reflection of the major issues that bring us together. If you're interested to join, please do not hesitate to contact Julian or me for more information. Now I wish you a very engaging and interface session, and I'm pleased to hand over to Harry Kulmala.
Thank you, Mr. Chara. Good morning, everybody. Good afternoon, everybody, wherever you come from. This session is very much organized for especially Asian and European friends. My name is Harri Kulmala. I work as a CEO of DIMEC innovation company in Finland, located in Finland. I have the pleasure to moderate this webinar as the member of steering committee of High Level Forum. This is a great event to talk about the artificial intelligence and the influence of that on our daily life, on the work life, and whatever comes next. We have three excellent panelists today, keynote speakers today, and two panelists in addition to that. I will introduce them all a little bit later. Today, we will talk about artificial intelligence, which, according to the study by Harvard Business School in 2023, AI will give us about 14% of productivity increase on average. We don't know if this is the real number. The later years will show us, but it is a big number in total. If you think about 14%, it means basically it's 1 out of 7. So it basically means 1 day per week extra to work with. If we think about current working days, for example. So could we take advantage of this productivity increase? Can we achieve it, and how do we achieve it? Today, we have 3 keynotes from different perspectives on AI in the world. First, we start with Dr. Yoshiyuki Sankai, who is professor at the University of Tsukuba and also entrepreneur. He works as a CEO of Cyberdyne. This is led from Japan, and he will talk about the human perspective on societal perspective on AI. So, Dr. Sankai, please, the floor is yours.
Okay, thank you so much. So it's great honor to have the meetings here. Okay, I try to share my screen. Can you see my screen? Okay.
Yes, perfect.
Okay, so anyway, today time is limited. Then anyway, I try to explain about our expensive nucleic acid drug appeared. So, but for the progressive neuromuscular disease. So by using this drug, 8 months later, it has peaks. But our technology, robotic technology's case, to fuses the human side together. So it has very excellent performances, of course. So we can combine these technologies, drug side and this technological side together. Current situation, there is no border between the different scientific fields, I think. And this technology also, this one, the lumbar versions, can be used for different use. So one of the important challenges for the such kind of elderly person case. So I try to realize that zero burdening care to increase the independency. And this lady always uses the workers. And so only 10 meters, she needs a 27 second, but the 7-time use or 8-time use, lady started to work by herself. So we can improve with such kind of severe persons. So, but even such kind of technology has a limitation. So now we try to combine the regional medicine and such kind of cybernetics technologies with AI. Just in front of Haneda Airport, I established the cybernetics biomedical innovation base. All rooms are wet lab. In these buildings, so robotic cell culture systems exist and try to develop the large neuron tissues or real 3 layers blood vessels and so on. But the regenerative medicine field is under developing. Then these robotic systems will work with the skilled biological researchers together. Anyway, these robots has such kind of AI autonomous control system, and also it has the cybernetic master remote control systems. Then these systems can be used for the remote uses or separate uses. So I tried to install some of the communication systems with the like a psychologist. Then we developed very important core technologies in the psychological fields. And this year, this journal paper opened this core technology for developing a psychologist robot also. And anyway, now we are trying to strengthen this core technology also. Yes, and in order to detect and recognize the human's internal informations, this one is very interesting. No X-ray, no contrast medias. Just in front of the patient, we can check the very narrow blood vessels, three-dimensional blood vessels. Then the robot system can recognize the patient situations. Every 30 seconds in the world, patient cuts the leg because of the diabetic disease. Okay, we can protect such kind of situations. Okay, so and we additionally developed the cybernetic vital sensor CYBIS, very small one to check the heart functions and physiological functions and so on. Okay. By using these technologies, so we can install this sensing technology to robotic hand and fingers, and these robot systems can recognize their friends like a person and so on. Okay, to check their physiological condition and so on. Okay, so anyway. So this technology is already prepared and application fields like this. Okay, so anyway, we gathered different types of humans, big data for the physical AI and cyber AI and so on. Cyber AI case, most of the case, text-based AI is now dramatically improved, I think. But the physical AI fields, so non-verbal areas, so this system can be used. Malaysia government decided to establish the National Neurorobotics Centers, okay, and Cybernetics Rehab Center. The size is 15.6 hectares. And this next February, so opening ceremony will be held. And we promote these challenges over 20 countries now. So worldwide, these HCPS, physical AI, and cyber technology is now gradually used in the real fields. This one is very dramatic case, I think. So now is the time to stop my talk. And in summary, HCPS SAI is a very important challenges which fuses cyber AI and physical AI. And so this is a new paradigm to drive the co-evolution of the human and the AI, and also symbiotic society will be realized by combining the human and technologies to support the to support the humans and robots mutually. Thank you so much.
Thank you very much, Dr. Sankai.
Yeah.
This was very good introduction from the human side, from the, to some extent, medical side, how humans and society are related to AI, how things might be changing. Now we are going towards second aspect of the so-called human side. How does the AI change our working life, the working habits? And we will have Tarmo Pajunen, Mr. Tarmo Pajunen from Finland. He is Chief Technology Officer and co-founder of an AI company called Brilliant. So Tarmo, please go on.
Thank you very much, Harry. Just to open up the discussion about work life and how it's really changing. I want to highlight one visible story and change. If you take a look at the academic research, the chemistry Nobel Prize winner 2024 was present to Demis Hassabis and his team working on protein folding. Very interesting and difficult case that chemistry has been trying to solve for 50 years. And but why I'm pointing this out, the interesting thing for me is that Demis Hassabis is not a chemist. Demis Hassabis used to actually work at computer games and now running the Google AI research. So you are able to actually do a cutting edge science and win a Nobel Prize today by being an AI expert. So I think this is a kind of a clue that, okay, something is really changing, and let's use the next 15 minutes on discussing that. But where my information is coming from, just to good to understand, it's not coming from academic research. It's by my own experience. I've been leading digital transformation offering before, working with change even before the AI stream, and now I used to be working 3 years at Europe's largest private AI lab, Silo AI. I've seen more than 200 production level AI cases and coaching C-level and executive teams on many stock listed enterprises and companies, and of course building my own company to tackle these issues. So when I talk about AI, I really like to always frame it up to a larger picture here. So it's not a single technology, as you know, and also the change how it's affecting our working life. I think it's good to state that this is not the first change that is happening. I like to talk about these three stages here just to give a bit more kind of time horizon also for the change. Like in the 80s, software started to come from the mainframes to the office, and Excel started to change our working life. There were digital skills, and the product changed. The product started to become hardware and software, and of course huge change. And then that continued for like 20 years. The focus was on digital, and I'm sure that you've been experiencing that change in working life. But then on the 2000s, the focus heavily shifted to connectivity and internet. And think about that change. What kind of effect has that been actually in the working life that wasn't so obvious in the early 2000s? Like, imagine this event happening over internet. we are working in hybrid mode, we are working in remote mode, and what kind of new skills and talents we have. I think it's good to frame that now we are transitioning in similar era of change with intelligent solutions. And I'm going to present here my kind of, let's say, early signs what is today happening. This is more like what is the situation currently at the companies, how are our roles and organizations and processes changing. But I just want to give that kind of time frame that the change is not 2026 change when it's going to happen, but this is, I would suggest that like 20 years of era of intelligent solutions that we are going to see this evolution in the working life. And what does it really mean? Because AI is such a complex topic, and it's really complex topics for the companies also who are trying to get the productivity and more value and growth out of AI. And I like to use this matrix. Somebody's changing the slides. Okay, that's good. This matrix to show in what levels the change is happening. On the lower left corner, we have the personal productivity, and every company, everyone is in that game. No matter, it's not a decision, but our personal productivity is changing because our tools are changing also. We are going to get these AI features and co-pilots and so on. But still, this is rather restricted. The transformation really do not happen yet on this personal level. It just iteratively changes our roles. But when we get really to the transformative change, when we go to the organizations and operations, after companies understand that, okay, we can improve the personal productivity, then companies are able to think about, okay, how do we really change our processes and roles and organizations by not focusing on personal tasks, but actually full processes. And then, of course, there are already companies who've been really transforming their products and kind of value creation. You know, they've been doing it for 10 years, 15 years, even many companies. But yeah, this is the highest level of value creation, and this really separates businesses that are they really looking at the internal productivity, or are they actually able to build intelligent products, and what kind of companies can actually do that, of course, affect our organizations also. What is the challenge? What is the key thing when you start pushing AI into your organizations? This is what I've really seen that is kind of course, the biggest value, but the biggest difficulty is to understand large language models that is behind the generative AI, ChatGPT and co-pilots. I've seen that it's really difficult for companies and even technology leaders and overall people to understand what kind of intelligence we are really using with LLMs. So it's really a new type of intelligence. Many people are expecting when they work with LLMs that they work as like computers. It has to be factual and deterministic, and there's no room for mistakes and things like that. And as if you used any large language models, you know that, okay, this is not how they behave. They are not deterministic, they are statistical. But then on the other hand, you might think that, okay, they are human. I'm giving them human type of challenges, and then you might understand, okay, it's not really a human intelligence either. So I'm saying that it's third type of intelligence, and we are really, really early in our understanding, common understanding that how do we actually use this third type of intelligence. And I would say the answer is that it's between the computer and the deterministic data and the human intelligence. I would say that it's a glue between that kind of knowledge and then the human human intelligence. But this is the struggle. This is one of the key things that we are not, if we are not finding the right role for the Gen AI and the intelligence. But how, when we take this third type of intelligence to our working life organizations, what are the effects that brings the change? I would highlight four things here. One is that knowledge becomes more accessible and available, and it's able to actually capture tacit knowledge from the organization, meaning that the value of knowledge is in the future a little bit lower because we are able to access it in automatic ways and in natural language, and this changes the dynamic quite a bit. Of course, automation, that is obvious, and the question is what type of things we are automating. But when the automation increases, of course, organizations change, our roles change, and the change can be huge. Even managing the change, igniting the change, steering the change in the right direction, this is actually giving a lot of pressure to many organizations already today. And of course, what is the new skill set in the age of intelligent solutions? So new type of personalities even and skill sets, I would say that might thrive in this new era. So AI automates individual tasks usually. This is where I at least start the journey. But the thing is that the roles about automating a routine task, or is it about orchestrating, judging work, designing work? That kind of roles actually will be even more valuable in the future. And as I stated, this is the key thing I would say that is happening at the moment. How we are utilizing the Gen AI. We are building these semi-automatic systems where we really capture the knowledge. For example, if you are working in the customer service, today companies are building supportive systems that the expert, when it gets the ticket, it's already included. The AI system has already included all the knowledge actually required to solve it. Going through the manuals, going through the tickets, and already not solving the issue, but giving information to solve it. And this really changes the dynamic, actually, what is valuable in the future organization. It's not maybe the knowledge, but it's about the capability to connecting and framing the knowledge in the bigger picture, because knowledge becomes, part of with utilizing this third intelligence. It's bridging the gap between humans and, of course, what is the change? How does it affect junior roles? I would say this is the big part of the change in a positive way, and in negative way, what we are seeing in software engineering is that the junior roles are a little bit disappearing because AI automation can do a lot of the work that juniors used to do before. But also in different roles, I'm also seeing different type of dynamic that actually, when you're able to access the knowledge more, the juniors can actually benefit from that. They don't need to work for 15 years to get all the knowledge, but they are able to access the knowledge through these Gen AI solutions. So actually they can thrive in the change, and they can bring new competencies actually in the mix. So in the future, deep expertise will be still valued in the organizations. That is not going to go away. And the human edge about communication, leadership, trust in the age of intelligent solutions will be highlighted. And of course, AI data skills, that is obvious. There are going to be new type of skills that are important in future organization. And I will still highlight, passion to improve and capabilities to thrive in the change and even thrive the change. It will be valuable. So I'm going to end my keynote. What I'm seeing that good leaders in age of intelligent solutions, what kind of capabilities they have. Ability to lead the change, ability to identify where information can be utilized, knowledge can be utilized, ability to define these problems into solvable chunks and see the business objective, understanding artificial intelligence. What is the third type of intelligence? Super important in future. Experimental and curious and having these personal successes with AI. I don't see that you are able to skip actually that, but you really need to understand it and see it to really utilize in the organization. So, and my final question here, what I'm seeing with the companies that are we I'm too much seeing that kind of just pushing to efficiency and efficiency and efficiency, but we need to go beyond efficiency. We really need to define our values and meaning and targets much more, solidly, because otherwise we are just creating that kind of productivity cult and nobody is really understanding what is the efficiency for, but we need to find the value why we are actually doing the efficiency and productivity. And this will be the main question for me that we need to solve to really create, humane and thriving work life in the age of intelligent solutions. And thank you.
Thank you, Tarmo. It was very, very intelligent ending because you already commented to the productivity discussion that has been started by the analysis of AI, which I referred to, for example, to the Harvard Business Review study. We continue to the world of robots. What is the robotics perspective on AI? And we have Dr. Weixiao Chen from National Taiwan University. He works as a consultant in ITRI as well. So, Dr. Chen, please, the floor is yours.
Okay, thank you, Harry. You can hear me, right? Okay. Can you also see the slides? Okay, sounds good. Okay, right. So thank you, everyone present and online. My name is Weixiao Chen. I like to talk about a branch of research in robotics called locomotion, and I also like to talk about the potential opportunities we have, especially in Asia and in Taiwan, in terms of AI robotics. Again, my name is Weixiao Chen. So these are the commonly referred to verticals for service robots, and as you can see, a few of these verticals has been mentioned before. For example, hospitality, healthcare, and agriculture. And there's things such as construction and consumer. For example, you have your vacuum cleaner at home. These are all possible verticals for service robots. And in Taiwan, we have quite a few companies directly involved or in part of the supply chain for this ecosystem. So to name a few here, I just won't talk about them individually here. In terms of their form factors, this is a slide from ITRI. As you can see, originally when we talk about robots, we talk about like a single arm, and then it becomes something that moves, and eventually it's got more limbs and it has more sensors to the right, and then eventually we're moving toward humanoid type of robots. And I just want to talk about how generally we would start building robots aside from hardware, right? So these are the open problems in robotics. We can talk about dexterity and how things get manipulated. We can talk about perception and how it does the reasoning. And we can talk about designs of AI models that can allow it to adapt to different skeletons, for example. And there are also issues about energy efficiency because these robots don't last too long when they're outside of the battery charging domain. And finally, we do need to talk about safety. But these are too many topics, so I'm just going to focus on how robots move today. So this is generally a good guideline from Gartner about maturity of different technology. As you can see, humanoid robots are still starting to get a bit higher and higher expectations from the industry, but it's probably still 10 years out. Whereas the ones that are reaching mobility, for example, autonomous mobile transport and light cargo delivery robots, they are reasonably close to reality, even though they are not hyped as highly as a few years ago. So you may have seen this recently. There's a robot from Xiaoping, China. This robot has a very human-like movement with very good articulation. And the fact is, it's actually, I mean, there are talks online speculating this might be a human inside the robot, but in fact, it's a real robot. But people would have too much of an expectation about it just based on the movement, because this is actually a remote control robot. It doesn't know too much about the environment, especially if you look at the floor. It's all shiny and flat, right? It could have difficulty just walking over pebbles, not to mention stairs, for example. And in particularly, if you think about it, the process of building robot may involve some safety issues. The one on the right is a video shot in a renowned company in China where the robot just basically went nuts, right? And I mean, it looks a little bit like the robot is doing this on purpose, but it's a little bit more because the robot is operating outside of its trained domain, right? It doesn't have the data of it falling down. So as a result, when it falls down, it goes crazy. Okay. So how do we fix it? Or how do we actually go about doing this? So I'd like to talk first about a framework called imitation learning and how the reinforcement learning is done. I would like to say that these are work conducted while I was at my previous employer, Inventec. You can look at this website, ai.inventec.com, for more information. And then I will talk about opportunities in robotics and categorize what we think might be a good way forward, in particular from our point of view. So when we want to imitate, when we want to get a robot to move, traditionally we would have a bunch of physics and we just run the physics. But these days, what we do is a data-driven approach, where on the left-hand side, you can see we actually got motion data from an animal that get captured into a skeleton. And then this skeleton may have more degree of freedom. So we remap them into a more of a robot-like motion capture data, right? From this data, we will learn an AI model called policy through reinforcement learning. So once this one on the right-hand side, you can see the green one is the original data from the reference motion, and the black one is the done result. And once we're done with this simulation in a digital world, what we usually call omniverse, for example, then because it's already simulated with a lot of physical parameters, this allows us to actually run this directly on the robot. So this is a research that we did a few years ago that was published in a very good conference called IEEE ICRA. What this does is essentially trying to map, figure out a way to transition from different motion. So in this case, this is basically pacing. It's a little bit walking a little bit slower. And then when it moves to trotting, it's walking it's basically rounding, right? If you look at the foot patterns, they're moving differently. So each motion is sort of robust by itself, but if you have to switch between them, it tends to fail, right? So the way to actually address this issue problem is, first we will just train a bunch of these individual policies where we call motions, and then we just try to switch between them. And this work created something called transition net that allows you to find a good timing for transition, such that when it switches from one motion to the other, it doesn't break down. And as you can see, that this simulation was done such that it will work for different friction surfaces and different terrain types, so that it actually would work properly without retraining. Okay. Now, this was about motion. The second work I'm going to talk about is about something similar to that robot going crazy. Okay, so basically, if you have a robot that's walking, is fine. But if you pull it up, for example, it never actually got pulled up in the training data, so it went a little bit crazy. Now, if you apply some technology here, it would know that, okay, it's not supposed to be picked up, so it will behave more like a cat rather than a cockroach like earlier, right? So in this case, we were able to get the robot to walk, basically stand on 2 feet, but without properly dealing with the AI, you can see that it will get really nervous, like the robot you saw earlier, the humanoid robot. Whereas if you apply a certain type of technology here that we presented here, then it would actually be fairly stable and it won't go crazy like earlier. Now, that was about the robotic movement, right? Now you need to know and figure out how to get the robot going the way you want it to go, right? So the easiest way, of course, is to plug in the controller to enable some velocity to it, right? So on the left, you can see a Bluetooth controller, I think a gamepad connected to the robot. And we use the same technology to participate in a robotic challenge. As you can see that this terrain is quite challenging for this robot because it has a lot of obstacles. For example, the bumps and up and downs. And in this case, they're gated beams with foam so that it actually would tumble a little bit when you walked over. The AI policy that you saw that we trained earlier were able to actually just navigate the terrain when we give it go instructions. So it would, in this case, it would just go forward and it would try to resolve the obstacles based on the AI that it was trained before. But as you can see, it's actually not doing a very good job, right? This has won awards, right? This is a bad technology. This is actually a world top-ranked technology here, but we still have a long way to go in terms of just getting it to move more naturally and more efficiently. Now, of course, once you know you can control that, you actually want to get the robot to move automatically, right? So on the left-hand side, you can see that we installed more sensors on the robot, and the insert of the real video is actually there's a digital representation that's shown up here. I'm sorry, up here on the map, and as you can see that it has a digital representation of what the robot sees. So this is simultaneously trying to find the location as well as trying to figure out the environment. And this is a common technology that's called SLAM, S-L-A-M, right? So if once you know about the environment, what's important is to actually figure out a path through the environment. And that's what the work on the right-hand side comes in. It knows about the environment, but it needs to know how to walk through it. So this work essentially creates an energy efficient path through the environment so that we could efficiently get to the destination where we want to go. Okay, so that's about the geeky part, right? Now let's talk about the opportunities. So if we look at the robotic technology stack in the AI era, it's a little bit different from the traditional ones where you have controls, you have modeling, right? So on the left-hand side, you have your supply chain and hardware. And on the rightmost hand side, you have your large language model like ChatGPT, for example. If you want to control the robot, you can give it instructions and it will follow, for example, right? The ones in the middle that glues the language model and the hardware are two things. First is the control and locomotion, and that's what I just talked about earlier, right? There's another essential glue, which is actually a essential technology here. It's called vision language action model. It's actually called this because it allows the robot to get from the video data, from the sensory data, and from the instructions into the actions for the robot. So this hierarchy, I think, is akin to how the human brain is constructed all the way from prehistoric eras to the common modern era. You have your reptile brain and you have neocortex, and then you glue everything together without actually abandoning the whole design. So if we look at it, I think our opportunity would be coming from the left to the right. We already have very good hardware and supply chain capabilities. Now, a lot of these AI powerhouses have been building large language models and vision language models, and our goal is to meet in the middle so that our locomotion and control is good enough for these vision language action models. So I'm going to give you an example of a vision language action model, which is a Gemini robot. So this work is particularly interesting because it talks about a very important problem of remapping a action from one robot to another. Okay, so sorry I had to mute the video so that it's easier to talk through. So there is a teacher, which is a human, that's manipulating a robot to do something, right? So it knows that this is a action of fetching something. And this teacher, this human teacher, is recording this motion essentially so that the robot can do it. It would capture all these video and all these location information of the robot. This is a Aloha robot from Stanford, for example. It has very good dexterity if a human controls it. But if you want to get the robot to do it itself, there's a lot of challenges. So a vision language action model allows you to do this. For example, in this case, the motion done by Aloha would be able to be used by this humanoid robot, even though this robot has never actually been trained on. So for example, this is to open the closet and then to fetch the clothes. So it's all using, this is called motion transferability. So this is, again, still a very open problem, but there's been quite a lot of progress recently. Okay. So, and this is important, for example, if you wanted to teleoperation. If, for example, this robot has only 2 fingers and has like different lengths of arms, and this human operator would have more fingers, for example, and then how do you map one motion from the other? This is actually also a problem that needs to be addressed. Anyhow, here are a few observations before I conclude my talk. First is that in terms of business, I think AI robotics, the corporate mindset would be mostly to address existing demands and through the process create a partnership structure and optimize for the current demand. Whereas startup mindset is mostly looking at new demand and create technology for a speculative future. But in a sense, robotic startups are not lean startups anymore because they are generally very expensive to create a robotic startup, even if you focus on only one domain. So our observation has been that the successful ones that we have here are mostly focused on building and optimizing for key components such as motors and wave reducers, these kinds of components, as well as addressing vertical scenarios that we only us have access to. And this would be our advantage to do these sort of startups here. The other observation is technology related. So again, you can look at hardware. Hardware is actually hard by definition. But in a sense, it's very easy to take apart and reverse engineer hardware, but it's just very difficult to be cost effective and reliable. So again, our take is that it would be more productive to focus on key component innovation and then have integrators or robot designers to work on integrating them together. And secondly, it's about software. So the locomotion software can be embedded in the motor control, for example, and these low-level messaging synchronization is very critical. For example, real-time operating systems for these software communication is critical. Otherwise, the robot would not function properly. And because there's already established market offerings, so we do need to match market offerings in terms of capabilities. But a word of warning is the long tails. Basically, existing feature set contains a lot of safety regulations, and all these reinforcement learning models would require a lot of out-of-date boundary data to be safe and secure. And finally, the models may not be readily transferable between instances and design, right? Even the same robot design, if you put in the same AI model, if there is a variance in production, it may actually break the model. So these are all the words of caution that we need to look into when we design technology for AI robotics. So this concludes my talk. Thanks a lot for the opportunity, and I'm happy to take any questions.
Thank you very much, Dr. Chen. I would like to go a little bit further with the extra panelists that we have. Certain comments from Senior Vice President from ITRI, Stephen Su, coming from the same direction as Dr. Chen. Stephen, how do you see this all that you have heard when you think about the Taiwanese world-leading semiconductor industry and all this chip thing that is related to the technology of creating and using opportunities to rely on AI? How do you reflect on this?
Are you able to hear me?
Yes.
Okay, all right, good. Regarding your question for Taiwan's role in semiconductor, especially related to AI, the topic of today, as many people know that TSMC is leading the way for the semiconductor foundry business, and TSMC was ITRI's second spin-off back in 1987. So over the years, obviously the industry, especially TSMC, is able to expand based on its core technology, and now it's building advanced factories for semiconductor foundry in Japan, in US, and soon in Dresden. And an observation to note is that not only the expansion is due to the need for localized semiconductor manufacturing, but also having to do with the connection to the key customers for that particular region. So, for example, U.S., there are quite a bit of cloud operators, and also the GPU companies. Then in Japan, that there is a connection with image sensor, automotive, and soon in Dresden, there is connection with automotive and industrial application. So naturally, we are seeing some sort of like a application-related supply network being developed, and that is good for Taiwan semiconductor development, because not only for foundry, that we have quite a bit of IC design companies that would need to connect and develop business partnership with the applications from outside of Taiwan, because Taiwan is not known for its branding companies or business, and therefore having this expansion piggybacking on semiconductor, but at the end, it's not all about manufacturing, but it's about the partnership with the downstream and the upstream together. And so recently, that I've been talking about, it used to be made in Taiwan, made by Taiwan overseas, Taiwanese companies overseas, and now more and more that we would see more partnership in terms of made with Taiwan. So for AI, it's quite an exciting trend for Taiwan. And again, Taiwan is a small country, and so we love to partner with people in different application and sectors.
Thank you very much, Stephen. This is great perspective. I would like to go to Mr. Gregorio Amiugo. You work as a head of AI interaction systems at CEA in France. There is a question by the audience. It's directed to cybernetic technology specifically, but I would like to open up this a little bit more widely. How do you see, Mr. Amiugo, the gap between the interests of research at the moment and the interests of practitioners when it comes to the AI?
Thank you very much, Harry. And this is a brilliant question. I would like to take a little step back before answering it, because you can talk about the interests of research, as in researchers, and you can also talk about what is happening also in private enterprise with the AI paradigm today, and those interests are not always aligned completely either. So if we look at where we are today, and I'm going to go from the semiconductor level up, I think that it is fair to say that Moore's law is getting more and more difficult to uphold. But that does not mean that there are not improvements that are going to be made. But what this means is that calculation is going to get progressively more expensive, computing. However, more than Moore, so that means multifunctionality and collecting data is going to continue to get cheaper and cheaper and cheaper. We can safely say that the availability of data, the explosion of data is going to continue. Maybe the future is not going to be so hyper-scaling, and this is important regarding the misalignment of interests. But we can safely say that we are going to be able to do more things with more data than we have today. And as Sankei-san said earlier, this data is no longer going to be only in the real the world around us. It is more and more within us. There are already 10 times more connected devices than people, even more than that, I think now. And more we're going to be able to gather data about ourselves, whether it is in a health context or in an industrial context. So we're talking about also that type of practice. So that does beg the question, what is the paradigm that we are building today? And when you look at the tech companies that are driving, I wouldn't say necessarily technology development, but implementation of the current generative AI paradigm, we are very much staying at the level where we have more and more data available, we have more and more computing power available, and we are going to try and overcome the limitations of this current paradigm with more data. Well, Wei-Chao was talking about this as well. So you have reinforcement learning as the solution for humanoid robotics. This is what is being touted as the solution. So if we have enough data and the VLA models that we develop will be more performant than they are today, and these robots will become useful and robust in everyday activities. But then again, when is that going to happen? How long is that going to take? Yes, we're talking about 10 years. I think Wei-Chao mentioned this as well. And that is not what is being touted today. And that is not what is being said to companies today. It's being said that it's going to work very much sooner. I would say 3 to 5 years maximum, and that it's going to be able to solve all of these problems. And I think we are not yet at the stage where we can say safely deploy purely data-based solutions. Now, the type of things that we're doing at CEA, I think also at ITRI and in many other places, is trying to focus first on how to improve the performance and the trustworthiness of these new robotics and AI paradigms, because the problem becomes bigger when you make it physical. But also, if you look at software, we do have that problem. And there is a lot of work in hybridization, which for me is natural. So you have a new paradigm, this AI paradigm. It gives you huge opportunities if you leverage data. You try to improve it. And then when you begin to reach an asymptote, and today you have, I think the people that are working on this that have talked to us are also always around 70-something% success rate for humanoid architectures, for AI-driven robotics, and 71% will not cut it, maybe for entertainment. So you have hybridization, the use of world models. This is something that we are more and more working on. So, well, if you have the data, rather than make it opaque, try to have an understandable and interpretable representation, a digital representation, and you develop your AI and your agentic AI, if you want, based on that, rather than just take the data and have a black model. So we are improving performance and trustworthiness. The jury is out as to how fast for very complex architectures. And we need to begin to look at the resources and the energy that we're taking, and the economic and social impact. I like very much what Tarmo said earlier. And we have a productivity code today. This is what resonates. And however, the implementation of AI that is being done today in companies is very often very fragile. And I think this is where the bubble is coming from. You deploy models that are still opaque, that are still not able to adapt to new situations. Because, well, Wei Chao said as well, it's out of distribution data. Well, what happens when you encounter a new situation? And yes, you can remove 7,000 people at a time in a large company for customer service, but wait until you encounter a new situation, and wait until you need to solve a human problem. So we're working, and I think I will leave it now so that we open the discussion, but we're trying to work on different ways of implementing artificial intelligence that move towards sharing a situational awareness, first between people, through these representations that can be built through AI, and between machines and people as well. So you can give high-level orders to robots and machines. And again, Wei Chao talked a little bit about that earlier. And you can basically improve the communication between humans and human organizations and the machines that should be at their service. And my last comment, also coming back to Sankei-san's presentation, which I loved, is that you have two possible basic implementations of robotics. And one of them, which is very popular today, is it's an exponential paradigm where more and more robots will be more and more present everywhere. And here, the jury is out as to how they will be at our service and what is going to be their impact on the resources and energy that we have available. And the other one is more linked to humans. And it's how can this data and mechatronics-based solutions, which do use materials that are not infinite, how can they service us and make our lives longer and allow us to interact more with each other? And please, 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 knowledge is still critical. We need to keep, because Tarmo, you said that earlier as well, knowledge and accumulating knowledge as humans is still critical, not only to function, but to have a good human experience. And if we outsource that, then the future is not bright. But there is plenty here to build a paradigm that I find could take humanity further.
Thank you, Gregorio. This was very, very holistic answer to my question. let's think about human errors and the errors made by artificial intelligence systems, or if I put it like autonomous systems. We have classical examples from traffic. There is a question by audience. Think about a car having many kinds of cameras and sensors, and still it can't make a difference between moonlight and yellow traffic light in certain conditions. The yellow traffic light may be interpreted as moonlight and the other way around. If I think about options, how we reflect to collisions, if an autonomous car crashes a human, there are big headlines in all newspapers blaming the autonomous system. But if a normal human hits an ordinary pedestrian, this is not a topic globally in newspapers. So I would like to have your opinions in the we are closing to the end. I would like to hear your opinions, both the panelists and the keynotes. How do we reflect the errors? And maybe Tarmo, maybe you will start.
Thank you. This is a really important question, and I really like this framing. As we have the robots, we have the autonomous vehicles, and then we have the organization. So I'm going to give a kind of quick reflection from the organizational side about how I think about LLMs and AI as the third type of intelligence. And yes, there are certain applications that we can't do mistakes like the autonomous drivings, but actually think about like coding, writing software. So we already have a processes where we can manage a situation that a human coder usually creates like 2,000 lines of code per day, but only 200 lines is actually production quality. And this is the situation in many organizations, that we already have processes and guardrails in place where we manage the human errors already. And we've used to do that for thousands of years, but now we have the AI. And I believe that in many cases, actually, we can build that kind of processes and guardrails and organizations behind it, that we can actually manage that kind of errors. And I think we have to, if we are going to work with LLMs and create that some kind of sensible productivity. But that doesn't solve the issue for the robotics and cases where you can't do mistakes. So understanding where we build that kind of processes that are kind of self-healing, they can manage the errors, and separating that from the cases that we really need to technically solve it.
Okay, Dr. Chen, how do you see it? Sorry, we don't hear you. Please make your...
Okay, hi. Okay, right. So I think this is a interesting ethical question in a sense, right? So I think the quick answer, like Gregorio was mentioning earlier, is because we created these AI in the lab, we didn't have data for the moon. It's out of distribution, so the AI doesn't know the traffic light from the moon, right? That's the easy technical answer. The more difficult answer, I think, is that how many of these exceptions do we see when we deploy them to the world, right? We can always see more and more of these exceptions out of order distribution data when we deploy them to the world. So I would say that 3 to 5 years, we can see humanoids walking around, but the 10-year estimate from Gartner is perhaps because in order for them to become trustworthy, all of these corner cases had to be collected. Just think about the vacuum cleaner in your house, right? It was first created 20 years ago, but it's still sucking up, dog poop right on your floor, right? So there's all these exceptions that we need to deal with. That's the one thing that I'm concerned about. The other thing is that the stochastic nature of AI makes it particularly scary, right? So every time when the traditional machine makes the mistake, it makes the same kind of mistake. Whereas AI, by its nature of wanting to be robust, it becomes more stochastic, it becomes more random. So it's actually very difficult to predict if the AI is going to behave normally or not normally in a particular situation. So I think there's still a lot of work to do in terms of trustworthiness. But despite that, I want to quote a very famous professor. When we were working on computer vision problems 15 years ago, nothing worked, and we're still working on them. And the answer that we got from the audience about this situation where nothing works, but why we're still spending all this energy making it work, is because it's an incredibly important and difficult problem, and partial solutions are useful. So we'll still keep deploying the partial solution, but we should make sure that they're deployed in a safe and sound environment. Thank you.
Thank you very much. Stephen, how you see the human error compared to errors made by AI?
I do feel like while humans' intelligence would be stable over time, the intelligence of computer or AI will be moving ahead extremely fast or faster. And so it is a good issue to think about the problems caused by the computers or AI. But I like to echo what Gregory has mentioned about human. So on the opposite end of the spectrum is how do we enhance or maximize the value of human. So I always encourage each researchers to develop technology that would put human in the loop, meaning that it's easy to do automation. But when you have people, we have people's constraint to augment people such that the sum of a human and a computer is greater than computer alone will be challenging, but I think will be very worthwhile in the future, because when people get threatened, they will resist. So it's not a technology issue. It's a ethical, it's a human value issue, and that's something I really like to phrase it as AI with people or with a human in the loop.
Hey, thank you very much. I think we have used most of our time. I would like to thank all the keynotes, all the panelists, all the participants. And as the last word, I would like to invite you to Grenoble in France next February. We will have the physical meeting, physical discussions, a lot to be seen in one of the greatest innovation ecosystems in the world, in Grenoble in France, in the beginning of next February. If you want to join, please connect Julien, please connect the organizing team, and maybe we can continue these discussions with much wider audience in Grenoble. See you there. Thank you very much.
Okay, thank you so much. Bye. Bye-bye.
Thank you
very much.